lecture on partial fraction decomposition. We will pretty frequently just abbreviate this to PFD when I'm referencing it, at least. Okay, let's look at the main idea here. So, quick review of rational equations. Let's say we were given negative 7 over x plus 8 over x plus 1. So if we were trying to combine this, sort of like we need to do in rational inequalities, right, to give us one fraction, what would we do? Well, we would first identify the least common denominator, right? LCD. We'd look at the first denominator, we'd say, okay, I need a factor of x. We'd look at the second denominator, we'd say, okay, we have x plus 1 as a factor, so we've got to add that in. Then that's all of our factors, so that's our LCD. We notice this first term is missing x plus 1, so how are we going to get that underneath? Well, we multiply. And in order to not change this, we need to make sure we're multiplying by 1. How can we create 1? Well, we can just put x plus 1 on top. Anything divided by itself is 1. So we're good. We've added a factor of x plus 1 on the bottom, and we've also not changed this term. We have to do the same thing with the 8 over x plus 1. What are we missing here out of our least common denominator? Well, we're missing a factor of x, so we can multiply by x over x for the same reason. We combine here. I'm going to sort of skip a couple of steps just for time's sake. We know that we're going to end up with the same denominator underneath, so we can combine these guys like this. We continue here. We have x times x plus 1 for both, plus 8 times x over here. We want to combine all the terms on top. We've got negative 7x minus 7 plus 8x on top over here over x times x plus 1. And this becomes x minus 7 over x times x plus 1. So this is the combination of these two fractions. So we've got one rational function over here out of the sum of these two rational functions. So the idea here is that we've taken these two rational functions and we've gotten out this one rational function. We've done this before. We've done this with rational inequalities. The idea of partial fraction decomposition is sort of reversing this. So taking something like this and splitting it up into two rational functions with the factors of the denominator. So how do we do this? So steps. 1, we want to factor the denominator if it's not already factored. Two, we set it equal to a, big A, over x minus r1 plus big B over x minus r2 plus big C over x minus r3, etc. for as long as we need to, where r1, r2, r3, etc. are roots of the denominator. So these are the factors of the denominator. 3, and this is where it's going to start looking like a rational equation. That's why we're doing this lesson immediately after rational equations, because they're very similar. Multiply each term by the denominator. 4, do all the cancellations like we did with rational equations. 5, and we'll see why this is important when we do an example. Let x equal each root of the denominator. To find big A, big B, big C, etc. You probably won't have to find this many or more than 3. I think for the most part you're only looking at 2. Last but not least, we want to write the solution. Okay. Before we get started with one of these, I would like to practice writing the partial fraction decomposition form of a function. So that's just this A, B, C, etc. So we don't have to do anything else beyond that. So for this first one, very simple. We've got 1 over the two factors are x minus 1 and x plus 9. So all we do is simply just write a over x minus 1 plus b over x plus 9. That's it. In order to do that for number 2, this hasn't been factored yet, so we have to factor it. Something that adds up to 2 and multiplies to negative 63. Sounds like maybe positive 9 and negative 7. So the partial fraction decomposition here is a over x plus 9 plus b over x minus 7. One thing I would like to point out is that it doesn't matter which order these are in. Even if you have a over x minus 7 and b over x plus 9, you'll end up getting the same answer. You just might have your numbers switched around. As long as you keep track of them, you should still get the same number to go on top of x plus 9 and the same number to go on top of x minus 7. Similarly here, looks like we've got the same factors. So here we've got a over x minus 7 could be a over x plus 9, and also b over x plus 9 could also be a over x plus 9. As long as you've got one and the other. Let's try one of these. So this guy. This is a question in the lab manual if you'd like to find it, but I'm going to do it here because I don't think they give you enough space. All right, so we start this one. It's definitely already factored in the denominator, so we get to skip that step. My second step is to set it equal to a over a factor plus b over a factor. All right, my next step is to multiply by the denominator. By design, the denominator here is the least common denominator for all of these, right? Because we created these by creating one for every factor over here. So these factors should be accounted for over here. So this is always going to be our least common denominator. So like we would do with a rational function, right, or with a rational equation, we are multiplying by the least common denominator because we're multiplying by the denominator, if that makes sense. All right, we cancel. So both of these guys are going to go. X is going to go here, and x plus 1 is going to go there. That means we're left with x minus 7, x plus 1 times a, plus x times b. Okay, our next step is to let x equal each of the roots. So what are my roots of my denominator here? This gives us a root of 0, and this gives us a root of -1. Let's try x equals -1 first. So what happens when I do this? Well, I plug in -1 for x over here. Don't forget to plug it in on the left side. For some reason, folks forget to do it on the left side all the time. -1 plus 1 times a plus -1 times b. We end up with -8 equals, this becomes 0 minus 1 times b. Why is this significant? Well, if this is 0, then this goes away, right? So we're left with -8 equals -1 times b. So b is 8. Awesome. What happens when x equals 0? I reckon it'll be pretty similar. We've got 0 minus 7 equals 0 plus 1 times a plus 0 times b. That one's even more straightforward. We end up with -7 equals a, right? 1 times a. So just a. Now we can write our solution. We know we've got a over x, and we also know that a is -7. So we've got -7 over x plus 8, right? B is 8 over x plus 1. And that's our answer. This is the partial fraction decomposition of this, right? It's two fractions, so partial decomposition. We've decomposed it into two parts. Let's say we've got f of x is 5 over x minus 1 times x plus 3. We're lucky that this is factored, but if it wasn't factored, we could easily factor it, right? So our first move is to just go ahead and write it in its partial fraction decomposition form. We multiply by the denominator, which is the LCD here. I'm going to have to tighten up so I can squeeze it all in. Yikes, just barely made it. A lot of stuff is going to cancel here, right? So we're just left with 5 on the left side equals x plus 3 times a plus x minus 1 times b. So my roots of my denominator are from here, positive 1, negative 3. When x is 1, we have the following. So 5 is just 5. We have 1 plus 3 times a plus 1 minus 1 times b. That simplifies to 5 equals 4a plus 0b. 0b is out of here. We end up with a equals 5/4. If we let x equal negative 3, we end up with 5 equals negative 3 plus 3 times a plus negative 3 minus 1 times b. We simplify this, we get 0 times a plus negative 4 times b. A is gone now, so we end up with b equals 5 divided by negative 4, or negative 5/4. So let's go ahead and write this in its partial fraction decomposition form. That tells us that f of x is going to be, right, we said a over x minus 1. So a is 5/4. So we've got 5/4 over x minus 1 plus negative 5/4 over x plus 3. We don't want to have fractions within fractions typically, so let's bring this guy down to the denominator. So we've got 5 over 4 x minus 1 minus, right, I'm going to bring that negative out, 5 over 4x plus 3. So this is my answer. I would accept this on a test for sure, but WebAssign will probably, I think, wants it this way. This one's also coming from the lab manual, but again, doesn't have enough room. All right, first step here, what do we have to do? We've got to factor, right? In order to write down our partial fraction decomposition form, we have to find the factors, right? And if we don't have it factored out fully, how can we tell what the factors are? So let's go ahead and factor it out. We've got 5x minus 6 on top. Something that adds up to negative 1 multiplies to negative 12. I believe we've got negative 4 and positive 3. So we can go ahead and write the partial fraction decomposition form. We've got a over the first one plus b over the second one. And of course, if you factored it in a different order and you have it swapped, maybe a over x plus 3 and b over x minus 4, totally fine. You'll get the same answer in the end. Okay, let's multiply through by the denominator. And after you get some practice, it may be totally within your wheelhouse to do this canceling without writing all of this out, right? Maybe recognizing like, hey, I know that the whole denominator is going to cancel this whole denominator, so I only have to write this. Or knowing, hey, my x minus 4 is going to cancel here, so this is just going to be x plus 3 times a. That's totally fine if you want to skip this step. But I want everyone to feel like they totally know what's going on, so I'm going to go ahead and write it all here, just in case. Okay, so these guys cancel, these guys cancel, and these guys cancel. I'm left with 5x minus 6 equals x minus 3 times a plus x minus 4 times b. My roots here, I didn't leave much space for roots. What are the roots of my denominator? Looking up here. Well, it looks like we've got 4 and negative 3. So let's plug in 4 first. So we've got 5 times 4 minus 6 is 4 minus 3 times a plus 4 minus 4 times b. 5 times 4 minus 6, we get 20 minus 6, or 14. This should be plus. So this is plus here as well. So we get 7 times a plus 0 times b. b gets canceled out. I've got 7a equals 14. So a is 2. If x is negative 3, I get 5 times negative 3 minus 6. I get negative 3 plus 3 times a plus negative 3 minus 4 times b. 5 times negative 3 is negative 15. Minus 6 ends up giving me negative 21. Negative 3 plus 3 is 0. Negative 3 minus 4 is minus 7. A is canceled. We have negative 21 equals negative 7b, so b is 3. All this tells me that a is 2, so I have 2 over x minus 4 plus b is 3 over x plus 3. That's the answer. All right, y'all. That's all I have. These are very straightforward problems, I think. Yeah, I'll see y'all next time.